In this video, we will solve a numerical based on steady flow energy equation in thermodynamics subject and asked in the GATE examination during the year 2019. The problem statement is given here. You can read. The first step in solving a problem is to write the data given. The pressure at inlet is given as 100 kilopascals. Initial temperature is given as 27 degrees Celsius. Volume flow rate is given as 15 meter cube per second. Heat lost is 51 kilowatts. Work input is 101 kilowatt. Cp, that is the specific heat capacity at constant pressure, and gas constant R are given as 1 kilojoules per kilogram Kelvin and 0.5 kilojoules per kilogram Kelvin respectively. What is asked in the problem? That is, we need to find the final temperature T2. It is given as exit temperature. And in the first data, pressure at inlet, we can use a symbol P. What is the solution? A pictorial representation of the problem statement is given here. So there is an electric heater and air flows through the duct. The initial conditions are shown here. And we need to find out the final temperature. The work input for the electric heater is 101 kilowatts. The gas loses a heat of 51 kilowatts to the surroundings. From the definition of specific heat capacity at constant pressure, we can write enthalpy change between state 1 and 2 as H2 minus H1 is equal to m dot Cp T2 minus T1. Observe this equation. Our aim is to find out the quantity T2. T1 is given. Cp is given, but the value of m dot and H2 minus H1 are not given. If we are able to find change in enthalpy and m dot using the other data given in the problem, then we can estimate this T2. To calculate H2 minus H1, we make use of steady flow energy equation, assuming the mass of gas entering is equal to the mass of the gas leaving. The steady flow energy equation is given as, in this equation, neglect velocity at the exit, velocity at the inlet, also the potential energy difference between the inlet and exit, since no data about them are given. The steady flow energy equation is rewritten like this after neglecting potential and kinetic energies. M dot is the mass flow rate, H2 minus H1 are the specific enthalpies. A product of them gives the total enthalpy capital H2 minus capital H1. The value of Q dot and W dot are given in the problem. We can substitute. Q dot is minus 51 because the heat is lost by the system. Work transfer is minus 101 because work is done on the system. The system is the gas. This yields change in enthalpy is equal to 50 kilowatts. If we are able to calculate the mass flow rate, then we can find the final required answer, the temperature at exit. To calculate m dot, we make use of ideal gas equation, which is PV equal to m dot RT. This can be rewritten as m dot is equal to P1 V1 dot RT1. Here V dot is not shown. We need to use V dot because mass we need to calculate in rate form. Also, in the problem, volume flow rate is given, therefore dot. On substitution, P1 V1 dot R and T1, the value of m dot is given as 10 kilograms per second. On substitution into this equation, the various values yields, instead of H2 minus H1, we substitute 50. M dot is 10, Cp is 1, T2, of course, the quantity we need to calculate, T1 is 300, and this yields T2 equal to 32 degrees Celsius.